All right. Hello and welcome to a video, an exciting video about EKG 431. So, as I said, I kind of just want to go through some of what's going on in this code, go through some of the examples. This is the factorial example. So we have some high-level code over there on the left. We're then compiling it, and we create a function. We're going to call factorial. It's going to do some stuff. It's going to then call itself because it's recursive, and then eventually figures it out. So we're omitting the multiplication code. All right, so we have a virtual machine program. This is kind of what it looks like. We have a function with 0 local variables called main, a function with 0 local variables called factorial, and a function with 2 local variables called mult. And we're going to start running through what happens. All right, so let's look what happens as we run this program. We hit function main, and then we're running through that. So it's like the initial program we're doing. So we have the global stack. We're going to push the constant 3. Now we're going to pass that argument to factorial. We say call factorial with 1 argument. That's on the stack. All right. Then we're essentially going to pause time. So we save all these memory segments we have, save the next return address. That all gets saved on the stack. So that then when we want to return, we can then basically just put all this back on, and it's like magic. We're right back where we were. That's I think it's so cool. It's the beauty and magic of what's going on. All right. Anyway, we saved the stack frame is what that's called that. All right, now we're in factorial. We're running factorial. We've set up. We have 0 local variables. Nothing really needs to be done on the stack. All right. Push argument 1, push constant 1. Sorry, push argument 0, push constant 1, whatever. They all go on the global stack, but really we're not going to look at those. It's just we push 2 arguments, compare them, and then we have an if go to. As you know, if go to pops that off the stack, so nothing essentially changes at that point. Okay, now we're going to push 2 arguments onto the stack, push the constant 1, subtract that. So now, since we've called 3 and 1, so you can see what we have, we now are ready to call factorial again. So we call factorial. Okay. At this point, what that means is that 2 is going to be our argument on the stack. And so now we call factorial with 1. We save the stack frame of where we are, go right back to the top of factorial, start all over again. We do the same thing. No impact on the stack. Push argument 0, push argument 0 and subtract 1. And now we would then have this stack frame. We call factorial again. All right. That means we'll make a new stack frame, save that, there's an argument, do all the stuff where we save and go back again. All right, here we are. So now we're back in factorial, do the thing, impact not shown. We're then going to do the comparison in this case, and that gets us down to this base case. We push the constant 1 onto the stack. All right, so that's what it would look like, and now we're going to call return. Okay, when we do that, we're going to get the return address of where we push that onto the stack. So we get that, which tells us back in this case when you go to over here at call mult2. So we get the return address. We handle the return where we copy the return value we want to return back onto argument 0 of our global stack. We then undo all those memory segments we saved, put them back where they were, so that now in this stack frame, and then we're in the, I leave the green dot, it's right back where it was before. All right, now we call mult2. Not going to show what happens. We just multiply what the 2 arguments in the stack. And so 2 times 1 is 1. Here we are. We return from that function. And now we're in this now green stack, or our second time we've called a recursive function. We return from that. So we take the value 2, put that back at argument 0 to handle the return, get our return address saved, and now we just simply restore all of our segment pointers, and we are back. Now we're back here in the stack frame from the blue, call multiply by 2, 2 times 3 is 6. That's going to now get a return address, get that restored, put 6 back where we came from. And when we are done, now we are back up in the main function, and it looks like we just called any old regular function. Everything is back. We've now done that by saving the stack, going through, recalling the values we need, and coming right back to kind of where we were. So we're kind of like saving time, doing something else, then we can we can restore time by putting all the segment things back into their place. And that is the magic of what's going on with the stack. So the main function wanted to compute 3 factorial. It pushed 3, call factorial, got 6. From the callers, nothing exciting happened, main just called a function and it got a value, and that's it. That's all it has to worry about. That's the cool thing. It can be oblivious to all this, what's going on. So the analogy, of course, I like their example of this. It's an iceberg. To the main function, nothing big's going on, but there's all sorts of complexity underneath, and that's kind of what your job is, to put that in the program. All right. Good luck. That's the first part of the factorial. More coming later.